Hi guys, Dr. Kruse here. I want to talk you through how to write a function given a word problem. So let's start out with a nice, easy word problem. See if we can turn that into an equation. See if we can turn it into a function. So maybe Dad tells you to get your butt off the couch and go out and mow the neighbor's lawns for some money this summer. And maybe he says, "Hey, I'll give you the lawnmower." So he goes to Lowe's and he buys you a $300 push mower. Let's just think about the value of your business, as we go along, as we mow lawns. You start out, your business is worth $300. That's what the lawnmower is worth. And you haven't mowed any lawns yet. All right, let's go ahead and mow one lawn. Well, what's your business worth now? It's the $300 mower plus, let's say you mow for 20 bucks. You mow the neighbors, make them a good deal, and you mow their lawns for 20 bucks. The business value is now the $300 mower and the $20 income in your pocket. How about if we mow two lawns? That's the $300 mower plus the 20 bucks for the first lawn plus the 20 bucks for the second lawn. Now your business value is worth $340. And let's do it a couple more times and we'll kind of see a pattern emerge. Let's mow three lawns. So your business value is the $300 mower plus the first lawn plus the second lawn plus the third lawn for a total of $360 business value. Mow four lawns, 300 plus four lawns is $380. And you can see how I kind of took a shortcut there. Instead of writing all these plus 20s over and over again, just think about it. That is $20 four times. That's 4 times 20, or 20 times 4. How about instead of writing all these plus 20s, because mathematicians are notoriously lazy, we don't want to write these plus 20s over and over again. We'd rather write 20 times 4 because we're lazy, and this is easier. All right, multiplication is just a quick way of adding a bunch of numbers. So this line right here says 300, sort of says 300. Oh no, that's not quite a zero there. There we go, fixed it, sort of. That's not good. 300 plus 4 lawns at 20 bucks per lawn. All right, let's mow 5 lawns. Well, it would look like this: 300 plus 20 times 5. We mowed 5 lawns at 20, and that adds up to $400 business value. Let's go one more time. Mow 6 lawns. Well, you got the $300 your mower's worth, plus the 6 lawns you mowed at 20 bucks each, for a total of $420 for your business value. All right, so notice that I keep putting in 1 lawn, 2 lawn, 3 lawns. Notice how this number changes. That's going to be our variable. That's going to be our x. All right, the number that changes is your x. The number that changes is your variable. Variable means vary, and vary means change. So anything that's changing, that's going to be your variable. All right, what comes out of your function? Your function is all the math that you're doing in here. All right, it's the job you're doing. You're going to take the number you're given, you're going to plug it in, and you're going to grab your calculator and do the math. This is the function. This is the input, the number that you're putting into your function. And this is the output, all right? And the output is your y, all right? So a number goes in, you do some work on it, and a number pops out. This is input, output. This is x and y. So when you're looking at this, just kind of walk your way down the column here and look at what stays the same. Look at this 300. Stays the same, stays the same, stays the same. That doesn't change. That's called a constant. So when we write our formula, when we write our equation or our function, we're going to have a 300 right here because that never changes. Look at this, plus, plus, plus. That never changes. So our function is going to say 300 plus. Now look at the 20. 20, 20, 20. The cost of mowing a yard never changes. So the 20 is also going to remain the same. So these 3 parts are going to be part of our function. The only thing that changes is the number of lawns that we mow. So it varies from 4 to 5 to 6 to whatever. This is going to be our x. This is going to be our variable. So once you kind of create the pattern, and then once you write it in a shorter method, after you go through that pattern, you'll see what stays the same, and then you'll see what changes, and what changes is going to be your x. So we can write this as 300 plus 20 times whatever x is. X is the number that you're inputting. So 300 plus 20 times whatever x is. So if you mow x number of lawns, You can figure out how much your value is worth, your business value is worth, if you take the $300 for the mower and add $20 for each one of those lawns. So the number that changes is your variable. The number that changes is your x. All right? So writing the equation, we usually start with y equals. So y equals 300 plus 20x. We can leave the parentheses off here. So your business value is the $300 that your lawnmower is worth plus $20 times the number of lawns that you mowed. All right. The only thing that changes from here to a function is they use letters that maybe make sense to the word problem. So maybe for business value, I could use B or I could use V. I chose to use V for value. And that's going to be 300 plus 20. Well, instead of X, I can use L for lawns or M for mowed. I chose to use L. All right. And to make this official function notation, I need to write V in terms of L like this. So the value of my business depends on how many lawns I mow. The value of my business in terms of how many lawns I mow is 300 plus 20 times the number of lawns that I mowed. Okay, now I want to show you that your function could decrease as well. So make up your own story. Maybe you were given $300 worth of merchandise, and you have a warehouse. So you have a warehouse with $300 worth of merchandise. So the value of your business is $300. And maybe you get on Facebook Marketplace and you sell one of these hoodies or sweatshirts or whatever you have in your warehouse. And maybe that hoodie or sweatshirt costs $20. So you had $300 worth of merchandise and you sold one, let's call it a hoodie. You sold one hoodie at $20. So now your business value, actually it should be called inventory. Sorry, my mistake. I wasn't keeping up with the storyline. This is a measure of inventory. So we had $300 of inventory and we sold $20 worth. We sold one hoodie. Now our inventory is down to $280. All right, let's sell a second hoodie. So I started out with $300 worth of merchandise. I sold the first hoodie and now I've sold the second hoodie. And now my inventory is down to $260. And you guys can see the pattern here. As you sell more and more hoodies, your inventory goes down, down, down. Well, if your y value is decreasing, this is going to be a minus function instead of a plus function. If we write this a shorter way, like we did on the other problem, the next one would be, I had $300 worth of inventory, but I sold 5 hoodies. All right, so 300 take away 100. Now I'm down to $200 worth of merchandise. Sell 6. 300 minus 6 hoodies gets me down to 180. Sell X. What if I just want to put any number in here? This is going to be my X, the number of things that I'm selling. Well, it would be 300 minus your 3, 4, 5, 6. Those are your X numbers. Those are the numbers that are changing. That's your variable. So it'd be 300 minus $20 for each shirt that you sell. So start back over here and say Y equals, like this, 300 minus 20x. And then just change your x's and y's to whatever variables they're using in the story. So maybe I could say, I probably should have changed that letter too. See, this is what happens when you don't proofread your notes. So maybe I could say my inventory depends on the number of shirts I sell, N for number. So inventory in terms of number of shirts I sell is the $300 worth I started with minus $20 for each shirt I sell. So just change your x's and y's to letters that make sense in your story. All right, here's a slightly different story. All right, let's read the word problem. You're selling lemonade, so you're running a lemonade stand, and you're selling it for 25 cents per glass. You invested $4 in ingredients. All right. First of all, before we get started with this, I'm speaking dollars here and I'm speaking cents here. I need to speak the same language. I either need to write these both as dollars or both as cents. Now I'm going to choose to write them both as dollars, so it would look like this: $4, or a quarter is part of a dollar. It's $0.25. So let's write them using decimal notation, which is dollar notation. We could choose to write them as cents. This is 25 pennies. Just think about pennies. So I could write 25 pennies, and then $4 would be 400 pennies. So I could use these. There's nothing wrong with that as long as you're speaking the same language with both units. All right? So I'm going to choose to speak dollars. I'm going to use the decimal notation. All right, it says write a profit formula. So profit is how much you make after you pay your expenses. So write a profit formula as a function of a certain number of glasses sold, N for number. Well, again, if you don't really know what to do, just start with a simple XY table. We'll worry about the letters later. And then this is selling 0 glasses of lemonade, 1 glass, 2 glass, 3 glasses, and just work your way through the table until you see a pattern emerge. Once you see the pattern emerge, you can see what stays the same and what changes. So how much profit did I have before I had even sold a single glass of lemonade? So what's my profit when I haven't sold any lemonade at all? Well, first of all, I'm in the hole. I had to go to Walmart and spend $4 of my own money. This is kind of like when you want to start a business. You have to go to the bank and ask them for a loan. So you'll start out, $100,000 in the hole because you owe the bank $100,000. Or if you want to go to college and you have to get a student loan, maybe you have to borrow $5,000 to pay tuition. You're starting out at negative $5,000 because you owe $5,000. You're not making a profit yet. So we started out $4 in the hole. We owe $4. All right. So that $4 came out of my pocket, and I need to put it back before I can start calculating profit. So we start out $4 negative, but we're going to add 25 cents every time we sell a glass of lemonade. So I start out at minus $4. Now, I sell 1 glass of lemonade. What's my profit after selling 1 glass of lemonade? Well, I'm $4 in the hole, but I'm going to add a quarter to my pocket. I sold 1 glass of lemonade. So now I'm only down $3.75. All right, I'm doing better. Let's sell 2 glasses of lemonade. What's my profit after selling 2 glasses of lemonade? Well, I started out $4 in the hole, but I got to put 2 quarters back in my pocket. So now I'm only $3.50 short. I'm only $3.50 in the hole. And so on, selling 3, selling 4 glasses of lemonade. Look at what stays the same and look at what changes. So this is a profit function. We're going to name it P. Notice that this number in parentheses, that changes. That's my variable. That's my X. All right. Notice that negative $4 stays the same. That's a constant. Plus, plus, plus. We're increasing by a quarter each time. 25 cents stays the same all the way through. And this is my variable. This is my X. Now they told us to use N for number of glasses sold. These are my numbers of glasses sold. So that's my N. And my function is called P for profit. So my profit in terms of number of glasses of lemonade I sell is the $4 I started out in the hole, but I'm going to increase by a quarter each glass. And eventually I'll dig myself out of that hole. Now don't be alarmed. I just want to show you this. Don't be alarmed if they put the 0.25 in right here and the negative 4 right here. That's fine as long as the 0.25 is positive like this and the negative 4 stays negative. That's okay. They can switch places as long as the signs go with them. Personally, I like to put the initial value right after the equal sign. The initial value is the amount you started with. All right. With the lawnmower question, we started with $300. That was our initial value, our starting point. And with the inventory, we started with $300 worth of inventory. That was our initial value, our starting point. I like to put where your starting point is right after the equal sign. This is your initial value. Back in junior high, you called this the y-intercept. Now, some people like to write it this way instead because it looks like when you're graphing, you have y equals mx plus or minus b. So this is the way you write it, if you're getting ready to graph something, but we're not going to graph today in this lesson. In this lesson, we're just going to practice writing functions. And when you're writing a function, just put the starting amount, the initial value, right after the equal sign. Tell me if it's increasing or decreasing. So it'll be plus if it's increasing and minus if it's decreasing. And then just tell me how fast it's increasing or decreasing. All right, let's look through this word problem here. You paid $249 for your iPod, and then you're going to buy some songs at 99 cents each. Write a formula or a function that gives the cost C. So we're going to name our function C for cost. The cost of purchasing the iPod and purchasing S songs. So it's going to be, what does the iPod cost, and in terms of how many songs you buy. All right, again, I do it by setting up a table. I look at what stays the same, I look at what changes, and then I can create my function. So my starting point, when I haven't bought any songs, all right, this is a cost function. Think of cost as money coming out of your wallet. All right, that's cost, that's expense. So my cost is going to go up and up and up. Every time I buy a song, that's more cost, that's more expense. So this is going to be an increasing function. We're going to be adding each time. What do I start out at when I've bought no songs yet? Well, it's just cost me $249. All right, that's my initial value. That's my starting point, $249. I like to put that right after the equal sign. What happens after that? Well, let's buy one song. All right, this is my X. Let's buy one song. Well, now my cost is $249 for the iPod plus a song for a total of $249.99. Let's buy two songs. Well, the cost for two songs is the $249 I spent on the iPod plus the 99 cents for the first song plus the 99 cents for the second song. Now, a shorter way of writing this is 99 cents times 2. So $249 plus 0.99 times 2 for a total cost of $250.98. All right, and we continue. Watch your pattern. Notice that your starting amount, $249, stays the same. It's increasing. My cost is increasing, so this is a plus function. How fast is it increasing? 99 cents every time I buy a song. The only thing that's changing is the number of songs. So I could start out saying y equals 249 plus 0.99 x, this is my variable x. So I could say y equals 249 plus 0.99x, but they want us to use the letters in the formula. So this is a cost function that depends on the number of songs you bought. So my x is going to be s. The cost, the total cost, depends on how many songs I buy. And I calculate it by taking my starting cost, $249, and I add 99 cents for every song I buy. All right, let's talk about depreciating a work truck. You can depreciate a work truck. A new work truck is $23,000. So maybe you're starting a business and you go out and buy a truck and it's worth $23,000. Well, a year later, after you've been doing business for a year, it's not worth $23,000 anymore. It's worth less because it's older. All right, that makes sense. So this is kind of a business value question again. What's your business worth? Well, it started out being worth $23,000, all right, for the truck. This is kind of like the lawnmower problem. I started out with a value of $23,000, but this value is going to go down as time goes by because my truck gets older and older. We can write that off, that amount that it goes down every year. I can write that off as an expense. I can say, hey, my truck is actually losing money, all right? If it goes down, let's say it goes down $1,000. If it's worth $23,000 when I started, but a year later it's worth $22,000, that truck cost me $1,000. All right, so that's an expense. That's a loss. This is going down. This is going to be a minus function. All right. Now the tax code, the IRS, they let you depreciate $1,500 per year. So they let you tell them that your truck is worth $1,500 less per year, and they let you call that an expense. All right, so write a formula that gives you the taxable value V after a certain number of years. So V, the value of your truck, depends on how many years have gone by. The value of your truck depends on the number of years that have gone by. The more years that go by, the less. It's a minus function. The more years that go by, the less your truck is worth. What did your truck start out being worth? $23,000. This is our initial value. Put it right after the equal sign. Is your truck's value going up or down? It's going down. It's decreasing. It's worth less each year. How fast is it going down? Well, they're going to let us depreciate $1,500 every time a year goes by. So the value of my truck after a certain number of years is the $23,000 it used to be worth minus $1,500 for every year that goes by. All right, I want to show you one last problem. Now this one is a little different because we're going to say we started at 50. All right, think of it as like an investment at a bank, or maybe this is a science problem and we started at 50 bacteria and maybe the bacteria doubled every month. All right, so it's something that's doubling. You can make up your own little story with this, but you have 50 to start with and then it doubles every month that goes by. Okay, all right, double. When something doubles, that means if I double 50, it's going to turn into 100. How did I do that? I multiplied it by 2. You guys see the difference? We're multiplying on this. This is not going to be a plus function. It's not going to be a minus function. It's going to be a multiplication function. And the key is the word double. If you see the word double or triple or quadruple, they're asking you to double it. That means times 2, or triple it, multiply it by 3, or quadruple it, multiply it by 4. So use your context clues here. If I start at 50, let's call them bacteria, and they double every month, that means I want to multiply this by 2 every time a month goes by. All right, let's start our table and just kind of bumble through it until we figure this thing out. So what did I start with? I started with 50 bacteria. This is when no time had gone by, when 0 months had gone by. Let's let 1 month go by. That means I have to double it. So y equals my initial value, my initial amount, that goes right after the equal sign, and they told me to double it. Every time a month goes by, I have to double it. Well, 50 times 2, if I double it, now I'm up to 100 bacteria. Let's let another month go by. Well, that means y equals the initial amount, what I started with, and I doubled it after the first month, and now I have to double it again after the second month. So 50 times 2 is 100, and then double it again. Now I'm up to 200. All right, here's a shorter way of writing repeated multiplication. You guys can see what's happening here. 50, double it 3 times, 50, double it 4 times. So we're going to double it the number of times that the month goes by. All right, here's a shorter way of writing repeated multiplication because, again, mathematicians are notoriously lazy. They don't want to write dot 2, dot 2, dot 2, dot 2. They said, let's just come up with a shorthand and let's just say that's 4 2's all being multiplied. Well, that's what exponential notation means. You have this many 2's all being multiplied together. So 2 to the 4th just means you have 4 2's and multiply them all together. It's just a short way of writing repeated multiplication. So 50 times 2 times 2 times 2 times 2, if it's been doubled 4 times, is the same thing as saying start with 50, initial value goes right after the equal sign, and double it 4 times. So 2 to the 4th means 4 2's being multiplied. All right, so if I write each of these using exponential notation, exponential means you're using an exponent, it looks like this. The 50 stays the same, the 2 stays the same. You're always doubling it. The only thing that changes is how many times you're doubling it, and that's your exponent. So it's going to be y equals 50 times 2. That all stays the same. This is going to be your x raised to the x. See how it matches your x's? 1, 2, 3, 4. 1, 2, 3, 4. That's going to be your x. The number that's changing, that's your variable, that's your x. All right? Remember, we call this initial value. Later on, when we talk about logarithms and exponential growth and exponential decay, we'll call this the growth rate. That's how fast is your 50 bacteria growing. Well, pretty fast. They're doubling, every month. So this is how fast they're growing. And then up here in the exponent, that's going to be your elapsed time. All right. Again, we can write this a number of ways. If we just use plain old x and y, it's y is your starting amount doubled a certain number of times. So y equals 50 times 2 to the x. If we don't have a story and we want to write it in function notation, we can just call our function f for function. So f in terms of x is 50 times 2 raised to whatever x is. If we're talking about bacteria, the number of bacteria depends on how much time has gone by. So you start with 50 and you double it however many months have passed, or years have passed, or seconds have passed, or whatever time unit they're using. I could say the number of cows as time goes by. So maybe you're measuring your herd. Maybe your herd doubles, every 10 years or whatever. So the number of cows I have as the years go by, as time goes by, is calculated by starting with 50, the 50 cows I started with, and it doubled this many decades. Every decade it doubled, something like that. This would be the number of decades. If it's a profit function, well, profit depends on how many widgets you make, whether you're a bicycle factory or a tennis racket factory or an automobile factory. We call those things widgets. And the more widgets you make, the more profit you make, hopefully. So your profit depends on how many widgets you put out. And we started with 50 widgets, but the number of widgets we put out doubled every year or every month or every week or whatever we're measuring by. Okay? All right, guys, that's all I got.